For over a century, one fundamental rule has governed the design of the internal combustion engine. It was an accepted law of mechanical physics.
For 130 years, you see, every single piston engine, without a single exception, was controlled by one specific component.
Just one spinning shaft. It controlled everything. We call it the camshaft. It's what determined how the engine breathed, and its decisions, they were permanent, final.
And then, one engineering team asked a dangerous question. What if we just delete it? What happens when you remove the one part everyone thought was absolutely essential?
So to really understand the answer, first you have to understand the problem. You see, an engine's main job is just to breathe. Air in, exhaust out. And for 130 years, that entire process has been run by a mechanical dictator.
The camshaft isn't just a component. It's a compromise, locked in steel. Its shape, the lobes on it, they're machined into one single fixed profile. And that one profile is supposed to be the one solution for an engine that has thousands of different needs.
Think about it. An engine at idle needs to breathe one way. At max RPM, it needs something totally different. Under a heavy load, it's different again. Cold start, the demands change completely. And the camshaft's answer to all of this is always the same, one fixed profile. Which means it's always, in some way, wrong.
Now, decades of truly brilliant engineering have been spent trying to cheat this limitation. You've heard of them. Honda's VTEC, BMW's Valvetronic, Toyota's VVTi. These were all incredibly clever workarounds, but they were still prisoners of the core problem. They could only modify the camshaft's behavior. They couldn't escape it.
Until Koenigsegg decided to take a completely different path. Instead of trying to fix the central controller, they just got rid of it. And that brings us to FreeValve. The whole philosophy here is simple, really. Decentralized control. Turn every single valve into its own independent, intelligent machine. So, how do they do it? Well, each valve is controlled by its own dedicated actuator. And this actuator, it uses three distinct forces, all working together in perfect sync. You have electrical signals, hydraulic pressure, and pneumatic force.
The sequence is incredibly precise. Here's how it works. Step 1. The engine's computer sends an electrical signal. That fires a solenoid. That's the trigger. Step 2. That signal releases high-pressure hydraulic fluid, which forces the valve open with calculated speed. And finally, Step 3. Pneumatic air pressure snaps the valve shut. This whole three-step dance happens with absolute precision, thousands of times, every single minute.
And right there, that is the fundamental breakthrough. The engine isn't following a mechanical program anymore. It's running software. It's executing code. Each valve can open whenever it needs to, for however long it needs to, totally independent of all the others. The engine has gone from being mechanical to being computational.
And when you shift control from hardware to software, all the old rules of engine design just become irrelevant. The limitations, they simply disappear.
The capabilities this unlocks are, well, they're significant. Suddenly, shutting down cylinders for better fuel economy is just a simple software command. It's not some complex mechanical system anymore. The engine can literally change its own combustion cycle on the fly, and it can even run in reverse, all by just changing the valve and ignition timing in the software.
The implication here is perfectly logical. If the engine can run backwards all by itself, then a car with that engine doesn't technically need a reverse gear in the transmission. A huge, heavy, complex mechanical part made completely obsolete by a few lines of code.
And this isn't just a theory. This tech is in production right now. Inside the Koenigsegg Gemera, its tiny three-cylinder FreeValve engine puts out 600 horsepower. To put that in perspective, that number surpasses the output of many traditional V8 engines with more than twice the displacement.
But the raw power, that's almost a byproduct. The real innovation here is intelligence. For the very first time, we have an internal combustion engine that can adapt its own physical operation in real time to whatever its environment demands.
So, the contrast between these two paradigms, it's absolute. On one hand, you have the camshaft engine, ruled by a fixed mechanical compromise. On the other, the FreeValve engine, which is run by software, giving it real-time intelligence. This system can constantly optimize for everything: altitude, fuel quality, temperature, what the driver is doing. In a sense, it's always learning.
Look, the camshaft was a brilliant solution for its time.
It survived for 130 years for a very simple reason. Nothing better existed. Now, something better does.
Now, the internal combustion engine, it might have a finite future. But the principle we see here is timeless. This idea of replacing fixed mechanical logic with adaptive software, that's a true paradigm shift in engineering. And it leads to a final, much larger question. What happens when more of our machines start to think?